Right, that you can,
gigawatts of
and it
heat
can
doesn't
concentrate, and liquid enables you
Right.
to concentrate the heat and then reuse the heat, which that's going to be a big focus, and I think for the Liquid Cooling Coalition, is getting that word out there and looking at the examples that exist in Europe. There's already requirements in some countries for doing this, and they have the advantage of district heating, which is a natural one. But here we see it's being used for agriculture, aquaculture, and I think that's a great business opportunity. Anybody who can figure out all the great ways to reuse the heat, because it's now concentrated, and you can figure out opportunities.
And there's a lot of value. I mean, gigawatts of value that'll be had from that.
I just want to add to that, Erica. I think your coalition is like in this industry at literally the perfect time, and I hope that it makes your job easier. We've actively taken data centers that operated at 10 to 15 kW to racks that now operate at 70 kW, and we did that through slapping a car radiator on the back of a rack, known as a rear door heat exchanger. That wasn't insane. That wasn't a very difficult thing to do, retrofitting a facility to be able to support that. But now this facility literally became an AI powerhouse because they can support that much more effectively. Now their next iteration, their next build, a 6,000 GPU farm, is going to have direct-to-chip liquid cooling. But to that extent, we learned a lot, Erica, and you're right, it is way more dense, it is more efficient. The inlet temperature going into one of those rear door heat exchangers might be like 76 degrees or something, but the outlet is like 72. 71 degrees. So all of a sudden, this data center operator is like, so you're saying I can remove some of these crack units, these crate units, inside the actual computer room? I can have less stuff in there because I'm much more efficient. I absolutely agree with what Dan said. It's simple physics. We've reached the limitation of how much air can dissipate heat from mechanical equipment. It's not a good thing or a bad thing. That's just a part of technological evolution. That's just the point that we're at. So kind of blunt. The sooner you accept that liquid cooling is going to be a part of your data center and ecosystem, the sooner you can start to explore that. And there are such fantastic ways to, no pun intended, dip your foot into the liquid cooling pool. That it's not that hard. Traditional co-location data center providers can absolutely become higher dense with really powerful liquid cooling technologies today.
So I guess one comment that I'd make is just, and it's similar to my prior comment on gas and other power technologies. It's you got to think about the end customer, and what I mean by that is, first of all, within our platform we are deploying liquid cooling in greater scale, kind of every year on the year. But the end customer that can do that are the large hyperscale, NVIDIA's, Intel's, the CoreWeaves of the world that have, reasonably unlimited amounts of capital to do that. But what I make sure that at least people are trying to appreciate this topic is not to make blanket statements over all consumers, because the enterprise may be considering liquid cooling and ultimately may increase the density of their infrastructure, but that's going to take some time and it's quite expensive, as I understand it. It's not something that we build for them, meaning they say, okay, I want a liquid cooling environment, and we'll get vendors to do that for them, but it's pretty dang expensive relative to an air-cooled environment, which may be more than satisfactory to run their CPU infrastructure that runs the predominance of their applications. And so I'm not saying I'm not a believer in liquid cooling, but it's there's like this segment of the market, hyperscale, AI, that certainly needs it for the workloads that they're doing, but there's trillions of dollars of investments on CPUs that are running workloads that are not going away over the course of the next decade, and probably
it's not going to be overnight. Yeah, I mean, that's why I said that if you want to be in the AI, the supercompute, the high power computing, that's the one that needs it immediately, right? And so that's where it's going to go first, because you've got all this other stuff that might not need it immediately.
And I don't disagree. It's just some of these blanket statements that it gets applied to the whole sector, meaning and then people say, well, you're going to have to retrofit your data center to handle these densities, and I'm like, most of my data centers are filled up with enterprise customers that are not going to. Their density is going to go up, but not to a point where they're going to need, the entire environment to be liquid cooling. Now we have our newer generation facilities, which are, we like to say, liquid cooling ready, because we run multi-tenancy environments, and again, the large-scale chip manufacturer can deploy liquid cooling fairly easily, but the large financial institution may not need it. So we sort of, we'll be flexible with how we deploy it in our environments.
And I want to pick up on that, because one of the things we've written about lately is hybrid data center design, where you're going to have some conventional air-cooled workloads living in the same facility as specialized liquid cooling. This was, one of the reasons why Facebook kind of, briefly halted its data center construction process to say, hey, look, we need to think about how we're designing for this new paradigm. And, they have a lot of workloads that are typical cloud workloads, but they're also going to have new AI stuff, and those have to live within the same facility. A lot of the multi-tenant providers are also thinking this way. They're introducing high-density cooling products, but at the same time, a lot of their customers, as Chris will note, don't necessarily need that, at least not yet. So facility design is changing. It's going to change even more. I want to talk briefly about the 1 megawatt rack. We are not going to have a 1 megawatt rack in 2025. I think the presentation earlier in the week by Schneider that sort of surfaced that and talked about folks in the mad scientists in the labs at NVIDIA who are designing for really powerful future stuff, but the point was also made that is the rack form factor gonna survive and be the same? You're not gonna pack a megawatt into the same 7-foot 42U rack. We're gonna see form factors evolve as as the situation demands. So there's lots of innovation to come there. Some of the data centers are going to look different than they do today, and we're going to see a certain amount of stratification and tiers of data centers. Some that are going to be all AI, just customized and specialized around those workloads, and others that are going to have to be able to accommodate a breadth of tenants and workloads that fall into both categories.
Thank you, Rich. Question now for Bill Clayman. Bill, excuse me, to what degree will the infrastructure for GPUs as a service and other AI and supercomputing demands have to live in specialized builds in larger data centers? And follow up to that, how compelling do you see the retrofit and modular options and opportunities in this area?
It's a great question. I'm gonna talk about both of those parts here in just a little bit. Could you repeat the first part? I feel like I read this over a couple of times, but I don't remember that first part.
It's your gig, or your friend's gig. It's to what degree will the infrastructure for GPUs as a service and other AI and see, I shoehorned supercomputing in there. I think that was wrong.
I was going to say, I remember this. But
let me remove that and just say, to what degree will the infrastructure for applications that seem pretty towering to us right now, like GPUs as a service, have to live in specialized builds and larger facilities? But then, harkening back to Tony Grayson's presentation, of course, we're talking about, the new distributed edge and modular, facilities that may also be accommodating AI. Is that a little clearer?
Yeah, that's good. So I'm going to answer that, but I have a little bit of a segue that I want to talk about. I mentioned this with Rich a little bit earlier. Before I get started, actually, kind of a personal note. I appreciate being on this panel with one of my dearest friends and mentors, Rich Miller, and I don't think I do this enough with him. He helped me get started in this industry and where I am today, and having a chance to be on this panel with him right now means the world. So I appreciate your earlier comments and everything you do for this industry. That's not a part of my answer, so don't hold that time against me. But thanks, Rich, for everything you do. So I really wanted to give this answer a lot of thought. And usually a Bill Clayman response is super cheery, very happy, and forward thinking and all of that. But I think my love for this industry and what I do in it requires me to talk about the risks as well as the opportunities that we're facing right now. And this will answer the question, certainly to some extent. And to preface this, I need you to understand what my company does, Apollo. Apollo.us was founded under a different name in 2019. And when it was founded, it was faced with an existential question. Do we build a platform for enterprises, or do we build a platform for data centers and telcos? And they went with the latter because they had a customer that was the size of AT&T and Verizon combined that said, we want to compete with Amazon, so build us a full services layer. So they did. Transitioning the company here to the United States in January of 2023, we became the industry's only true multi-tenant AI and MLOps layer built for data centers and telcos. There's no secret. We took a page out of Amazon's book and said, why should they keep winning? I have the software layer, I can put it in a facility, they own the entire process. Literally start, they're gonna buy the capital, but then they set the prices, they set the services. It's not a GPU rental game, it's the true services layer, network, storage, compute, GPU, and CPU, right? That full kind of architecture. Now that's important to know, because when we first started building this business, we realized a massive risk in this industry, and that's this GPU rental gamble that a lot of people are facing right now. For 2 months, we went after that market, and we noticed very quickly it was a race to the bottom. Like, who can charge less for a GPU per hour? And we quickly got out of that because we had something so much more to compete on. And one of the things I want to talk about, and the importance of retrofitting, the importance of understanding your risk factor in this market. Now, you nailed it. Not everything's going to be AI. Exchange servers aren't going anywhere. I still need my SQL database. But believe me, every data center is going to become an AI data center in some form or function to support that hybrid approach. So I took some notes here, and I want to make sure I talk about this. When we looked at that per hour market, we stopped immediately because we saw that the math didn't make any sense. We literally couldn't compete in that space. And one of the things that we've recently noticed is that while we're all very excited about this market, AI, generative AI, and the new B200s that are coming out, this industry is exceedingly muted on the continuing proof of the 18-month cycles of the planned obsolescence of the largest CapEx purchase in technology history. Like this was massive across the board. And one of the ways that we thought about it is, if you invest in 4 8-way H100 GPUs, shelling out a cool $1.5 million for those nodes, fast forward 18 to 24 months, and the shiny new B200 comes out. Now you got to have liquid cooling in there, and all of a sudden, it's doing the exact same work that you've been doing in the past for a fraction of the cost. A fraction of the cost. And so now you need to charge sky-high rental fees to recoup the investment. In our math, north of $3 million over the course of 2 years just for that gear. And even then, the margins, you're barely scraping by. In many situations, you're a loss leader. And it's something that we were very nervous about, that we looked at the math and it looked really, really hard. And it doesn't stop there, there's ripple effects. And I promise I'll talk about the opportunity here for the entire ecosystem. So suppliers like Dell and Supermicro, they rely on constant upgrades, and service providers like CoreWeave, they need to recoup their capital and turn a profit before this next generation of GPUs comes out. So this is where the risk lies. And I just want everyone to raise this flag and think about it internally. The speed at which these new GPUs are being released is far faster than any depreciation cycle we've seen, throwing traditional asset turnover ratios completely out the window. When we looked at it, we saw that to make this model work, traditional turnover ratios would need to be 5 or 6 times faster than what they used to be, and what we're used to specifically. So the accelerated depreciation is really what we saw as I don't know how to say this, a ticking time bomb for anyone that's strictly in that rental GPU game, because the constant need to upgrade leaves very little room for financial recovery or profit. So we looked at this market and we realized that that's not something that we want to go after, because there's quite a bit of risk. And one of the things that we noticed very quickly, and just to kind of point out, we at Apollo have an exceedingly unique purview, being a multi-tenant operator, what kind of workloads are being run. We see what's actually being built on these AI systems, on these GPUs, on these H100s. And Dan, you nailed it. There are 2 types of people in the AI game. There are model builders, and then there's people doing inference. Okay, so like inference at the edge, actually using existing models to create enterprise use cases. The people building models right now, those are the folks renting GPUs by the hour, and they're hoping to strike gold with a compliance model, or a regulatory model, or an automotive model, or a legal model, right? But when they get there, they still have to test it and validate it, and that's where you see those ebbs and flows, peaks and valleys. We said we're not going to do that. We're going to go after the inference market where it's a consistent load. It never drops down because the use keeps getting built. And the use cases that we go after are the low-hanging fruit of generative AI. The lowest hanging fruit. A customer of ours spends 10 hours to create one pricing spreadsheet. There's a template. We ingest the template, use a private model. Actually, it's Llama 3.1 405B, nothing into OpenAI. And now we've taken that 10 hours down to about an hour and a half, and the template is 80% complete and 99% accurate. And now we've created a full GPT template for this customer for networking services, for CPU, for all the stuff that they sell that's dramatically changed their sales process. That's just one example. We've done RAG, where a company can go in and ask PDFs questions. That's low-hanging fruit. That's stuff that makes impacts for enterprises right now. I've got banks, financial services, global marketing organizations running on Apollo in our data centers, actually using this stuff, not building models, doing inference. So in what we've seen, we've gone to traditional co-location providers, my partner Scott Data Center, and he's got 20 megawatts, and he's had multiple people come to him and say, I want to take every inch of that land. And he's like, absolutely not. I'm going to own this entire process. So he put forward a lot of money to put an 800 H100 GPUs, and hopefully by early 26, it's going to be a 6,000 GPU farm, all running Apollo, because there is a market for that. A price-conscious but not price-sensitive market that wants to keep their stuff in the facility, that doesn't want to go anywhere. They don't want to put their things into the cloud. But the only way you can support that architecture is if you retrofit, is if you actually look at the architecture in your data center. So Scott Data Center was a traditional co-location provider, 10 to 15 kW, and when we take a look at what they're trying to do, 115 enterprise customers that they already validated, they wanted to use this service. They put in motive air rear door heat exchangers, a 50+ unit rack that can handle 6 DGX units, all rear door heat exchanger from motive air, like I said, and they were able to put the manifold in underneath the raised floor, which by the way is going to make a huge comeback, and I think that's great. But in that sense, retrofitting the ecosystem to support liquid cooling was the best way to